In this video, we are going to learn how to find the features of a quadratic function in standard form. Now, standard form is y equals ax squared plus bx plus c. So instead of being parentheses where you can see those transformations, we have expanded that x minus h, and now we just have terms, an x squared term, an x term, and then a constant term. Now, reading this, if the a value is greater than 0, the parabola opens upward, and if it's less than 0, the parabola opens downward, which is very similar to what we've learned before. The axis of symmetry now is x is equal to negative b over 2a, which if we know where the axis of symmetry is, then the vertex is negative b over 2a, that x value, comma, plugging that value into the function to figure out what the y value is. And then the y-intercept, if I plug in 0 for x, a times 0 squared plus b times 0 plus c, these two terms go away and you're left with just c, making that c at the end the y-intercept. Now, these third and fourth bullet points are the more interesting bullet points, and I'm going to show you where they come from. So if we look at vertex form, if I were to expand this expression, meaning I take a times x minus h times x minus h and multiply those two binomials out, I'll get a times x squared minus 2xh plus h squared plus k. Distributing the a, I'll get y is equal to a times x squared minus 2ahx, and that a multiplies there, and then I'm left with plus a h squared plus k. You may be wondering why I'm coloring them this way. So you can see that this a is actually equal to the same a as in standard form, but the b here is going to be equal to negative 2ah when comparing it to that standard form I have up there. So after expanding it, I learned that b is equal to 2ah. So now, normally, I know that the axis of symmetry is x equals that h value. So if I take this expression and solve it for h, I'll learn that h is equal to b divided by negative 2a, which is negative b over 2a, which lines up with what my axis of symmetry should be. So that's where this mysterious fraction comes from. It's just expanding vertex form to see that, oh, okay, h would be this value. And then from there, if I know that's what the x value is, I can always just plug in to get the y value. And I'll show you what I mean with this with an example on the right. Because here we're going to find out what are the vertex, the axis of symmetry, the max or minimum value, and the range of each quadratic function. So first we have to find out what this x value is to start. Because you always want to try to figure out what your vertex or axis of symmetry is before you start figuring out anything else with the function. So here, plugging in the values I know, I get negative, and b here is 8. So 8, negative 8 over 2 times a. In this case, a is 2. So 2 times 2. So that'll leave me with negative 8 over 4, which is negative 2. So my axis of symmetry is x equals negative 2. Now let's use that value, because now I know that's going to be the x-coordinate of my vertex. Now let's figure out what the y-coordinate is by just plugging that value negative 2 into this equation. So 2 times negative 2 squared plus 8 times negative 2 minus 2. So 2 times 4 plus negative 16 minus 2. So that gives me 8. Negative 16 minus 2 is minus 18. So y equals negative 10. So now I know that since y is equal to negative 10 when x is equal to negative 2, that helps pinpoint what my vertex is. Because I know my vertex is at x equals negative 2. By plugging it in, I see that my y value there would be negative 10. Now, I need to understand, am I going to have a max value or a minimum value? Well, looking at the a value in front, it's a positive 2. So I know that that's greater than 0. So that's going to open upwards. So I will have a minimum value of negative 10. Since it opens upwards, that vertex is the lowest point. Now, knowing that's the lowest point, I'll see that my range will be anything greater than negative 10. So y is greater than or equal to negative 10. Let's try another example so I can go through that process one more time. So first, we start by finding that axis of symmetry. B, in this case, would be negative 4. Over 2 times a, in this instance, is negative 3. It's a lot of negatives going on here, so we're going to take our time. So we have negative of negative 4 over negative 6, which those negatives will cancel to a positive, but this negative will remain, keep the whole thing negative. So I'll get negative 2/3 for x. So I'm going to be dealing with a fraction here, but that's okay. Now let's go and plug that in. So I'll have negative 3 times negative 2/3 squared minus 4 times negative 2/3 plus 6, which gives me negative 3 times 4/9. When you square a fraction, you just square the top number and the bottom number, plus negative 4 times negative 2, which is 8/3, and plus 6. And it looks like when I multiply by 3 here, that 3 divided by 9 makes this a third. So the common denominator is going to be 3. So I'll have y is equal to negative 3 divided by 9 is just the 3 at the bottom. So negative 4/3 plus 8/3 plus 18/3. Again, I'm imagining this is over 1 and multiplying the top and the bottom by 3 to create that common denominator. And now I'll have negative 4/3 plus 8/3, which is 4/3 plus 18/3, which leaves me with 22/3 for my y. So my vertex is negative 2/3 comma 22/3. My axis of symmetry is x equals negative 2/3. Now, this is a negative a value, so my graph should be pointing downwards. So this will be a maximum value of 22/3. And the range here, since that's a max value, I know it's all y's that are less than or equal to that biggest value, which is 22/3. And that is how you find the features of a quadratic function in standard form.